Assalamu alaikum everyone. Today I will discuss about how you can use SimaPro software for LCA modeling. For starting, you need to have some sort of resources. Follow me in this tutorial. Let me share my screen. First of all, you need to download the software. If you have licensed software, then it's good. But in case you don't have that software, you can download the demo version from the SimaPro website. Just go to this web link and then go to the trial version of that software, download and install in your software. You need to have the tutorial you can find from the SimaPro website as well. So this is the tutorial of that SimaPro. You can download it and put in your desktop or whatever you want to keep. And another one is I have another life cycle analysis video. Just need to go through this one before starting this so that you can have your basic understanding of what life cycle modeling is. I will put this link to the description of that tutorial in this tutorial, including this one and this one. Also, for basic understanding of the SimaPro software, you can go to the theory of SimaPro, which is the introduction to LCA with SimaPro. If you can search this one in the Google, you will be able to find it. So all about what you need in order to follow through this tutorial, and I will start with this software step-by-step process. I will show you, and when you open this software, you will be able to get this interface here. I will demonstrate this one guided tool with copy. I will not define anything. Whatever it is defined, I will explain step-by-step processes. As I have discussed, I have another video in my channel where you can find the basic principle of life cycle analysis. Just to recap here, there are four main phases in the life cycle modeling. First of all, goal and scope definitions, inventory analysis, impact assessment and classifications, and finally the interpretations. All four processes I will go through in the software, which I can show you here. So first of all, it is goal and scope. If you click here in descriptions, if you go through all this, you will be able to understand what are the goal and scope of this study is. Click in the libraries. Library is the database of this software. Basically, we'll be using EcoInvent this database, but in other cases, depending on the situation or the processes, you might need to click in this agree footprint or other databases as well. But there is no harm if you click all these databases. And the third one is the inventory analysis, which is the process which consists of processes. And the processes you will be able to find materials, energy, transport, processing, use, waste scenario, and waste treatment. These are the processes. So you need to define your materials depending on the situations of the cases, energy, transport, and etc. etc. The third one is the method or impact assessment. In this impact assessment, you need to define your method. We will be using recap method, and I will show you in the while I will be discussing about the life cycle modeling for the coffee machine step by step, and calculation setup. So this one I will discuss in later. The final one is the interpretation of the results. Okay, so once I do the modeling in the software for the coffee machine, I will discuss these things. Now let's start with the life cycle modeling for the coffee machine. Analysis, I will be discussing about a coffee machine. Problem is find out what guidelines should designer of coffee machine. For instance, focus on metal section or energy efficiency in the case. Okay, so is the consumption of paper filter important? We also investigate if it is important to organize and recycle. So in this tutorial, I will try to make it as short as possible so that board. That's the reason I will skip some of the part and second phase here. I'll just try to make give the brief overview of the SimaPro software. And so I will try to skip some of the part and discuss later in the second tutorial. So in this tutorial, we have two types of coffee machine. One is made of plastic and aluminum. Okay, sorry. Main material for housing is plastic. One, the named as model Sima. The other one is a model Pro, which is made of aluminum. So we will compare these two in the second tutorial. But in the first one, I will try to explain this one first, the plastic one. And this model Sima, main material for housing is plastic, and the system for keeping coffee warm is what? Plate. And the same thing we will be discussing or generating modeling in this model Pro one, which is made of aluminum and thermoset. And then followed by that, we will be explaining or comparing these two and see which one is better in terms of environmental burden. So let's go to the software, but before that, I will be discussing a little bit of what the phase little bit further. So depending on your process, you need to select your materials. What are the materials you want to use in your system? For example, if your system contains metals, just go to metal here. Here metal, and what kind of metal is it? Alloy, extraction, ferroalloy, etc., etc. So click here and go to market. Then you will be able to find a lot of materials here, and depending on the context, you just need to select it here. So because of the demo version, probably we will not be able to select all those, but for this tutorial, I think what we need is available. Okay, so I'll move to the product stage, which is all the materials and energy are already defined for our cases, like the one I want to show you, like coffee machine, making life cycle analysis for the coffee machine. Okay, so I will go to the product stage. Okay, so this product stage you will be able to see this coffee machine demo. So this is already built in. So one is for the plastic, another one is for the aluminum. Okay, so this coffee machine is made of some sub assemblies, which consists of a coffee pot, housing model, housing pro, extruded aluminum, mains, cables, small parts for model Sima, and some of these other. The parts are defined in the process phases from materials and energy. So let me explain a little bit how we have defined or how it has been defined in the system. Okay, so go to the sub-assembly parts. For example, coffee pot. I will explain this one, and you can all those go through all those things. So if we double click in the coffee pot, you can see the materials are polypropylene granulate at plant and glass. And the processes are injection molding and heat in natural gas from natural gas. Okay. So materials, polypropylene, how it has been defined. Okay, so it has been defined from here. So polypropylene is, we know it's a plastic, so we can easily go to the plastics section. Search for the plastic. This is the plastic. Okay. Is it biopolymer? I don't think so. So this can be recycling rubber, thermoplastic. Okay, let's go to the thermoplastic, and you can search it polypropylene, right? So thermoplastic, go to market and just scroll down. Polypropylene is here. So polypropylene granulate, this one has been defined in the system because it is already defined. So we already have got it in the product stages. Unless otherwise you define in the process stage, this one you cannot get it in the product stage. So just double click here and then select like new, or make it new, or double click. Okay, input and output. Okay, go to the input and output, and is it from the nature, materials and fuels, electricity. So okay, so this is amount you need to define how much you want to put as thermoplastic or polyethylene, and thereafter you go to the input from the nature. And no, it's not input from the nature, input from the thermal materials and fuels. So just click it, add here. Okay, if you click add here, and then go to plastic and go to thermoplastic, it, and then polypropylene. If you double click this one, it will be selected as your materials. Since it has been already selected, I'm not double clicking or selecting it again, then it will be duplicating. Hope you have understood. So I'm not saving it, just close it. No. Glass. So another material is glass, which has been defined for this copy machine. If you go to the glass, it is glass, and it is the packaging materials. Go to the packaging and go to market, and glass. This one has been defined. The glass virgin materials. Okay. So this one you can just copy, and that will be added in the system. Okay? So I'm not doing that one because it has already been defined in the product that has gone to the product stage. In the product stage, you can see in the coffee machine, coffee pot. Under coffee pot, you will be able to see these two materials have been defined. And in the process, injection molding and heat is from natural gas. Okay. If you go to the material process and just go to the energy, for example, for the natural gas, I think it's in the natural gas section. Gas, go to the market, and you can see heat from natural gas. You can define this one or any of this one. Okay, and ROW means rest of the world. It is defined depending on the country you are analyzing for, but most other cases, like if you cannot find your specific country, then you can use rest of the world ROW. Okay, so this has been defined in the process, so I'm not selecting it again, and it will be duplicating. It has already been defined. Okay, so it has gone for the coffee pot. Similarly, for the housing model SIMA, if you double click it here, then you will be able to see what are the materials defined under this category: aluminum, polypropylene, and injection molding. So these are the materials and the process that has been defined in the system. Okay, so and then so this is inventory analysis. This is the most important steps, inventory analysis. Like if we can define all those things, then your results will be as perfectly as you can define the inventory analysis. Your results will be as perfect as you want or as you expect. So impact assessment. Okay, let's go to the impact assessment. Let's go assembly. Select our model. Okay, our model is plastic one. Okay, so double click this one. Okay, and then impact assessment is analyze. Just click here, analyze. You will get the impact assessment once you calculate. Okay, so at the bottom you will find the calculate option. Before that, actually you need to define the method. The method is receipt endpoint hash. This is the version of the method. So it is not, if it is like it is, since it is already built in, so it is already been defined in the system, so I don't need to define anything. But if you do the fresh analysis, you need to just double click here and define your method from here. So these are the method. So it has already been defined, this endpoint receipt method. So you select this one, and for all those methods, explanation for all those methods are given in the theory guide of the tutorial, which I have already explained in the first at the beginning of this tutorial. So we need to go through all this, but this is the most common goes on receipt method, endpoint, H1, or midpoint. Okay, so now just click calculate here. Okay, calculate. So you got the results. So this is our results. Now this is the time for interpretation. So impact assessment, now you have to just understand the results, and then you need to write down the results and interpret it. So you can see, okay, so this is assembly of model SIMA plastic. Okay. So housing, there are four main components. One is housing model, small parts, main cables, and coffee pot. These are the four main components. So these four components out of 0.9, this is PT means percentage. Okay, out of 100%, this is about 90%. The rest 10% is probably has gone to other aspect of this model. Out of 0.9 or 90%, this SIMA housing model contributes 45% in the environmental burden. 17% contributed by the small parts, and cables 16%. The coffee pot contributes another 16%. More breakdown here. So 0.1 kg aluminum is used for housing model. That contributes 0.07, that means 7%. And 33% is contributed by the use of polypropylene. It is used to 1.1 kg. These are the parameter actually you need to define. Like you need to know from the inventory that how much or how many kilograms of materials are used for making 1 kilogram or 1 coffee machine. Okay. Okay. So 1.16 kilogram of injection. This is the 1.16 kilogram molding RERS. I don't know what is that, but that contributes 13%. Okay. And so on. Okay, so each of the system or the materials contributes in the environmental burden, and that has been defined or calculated in this tree or network. This one is similar things, but here you can get bigger or smaller. So 11 nodes visible out of 20. Okay, here 11 nodes are visible here, and plus to the 20, but due to the very less impact, that has not been shown here. Okay, so this is impact assessment. This is one of the important things to understand. Like here, this is single score impact assessment. These are the four main components we have: housing model, small parts, contribution of the small parts, contribution from the cables, contribution from the coffee pot. Okay, and this one is categorized as a human health, ecosystem, and resources. The green one is human health, contribution for in the environmental burdens. While I say contribution, that means the environmental burden. Okay, so housing model SIMA. This housing model contributed 140 out of 400. This milli percentage. Okay, and ecosystem contributed like 140 and about 60. And the rest from 200 to 400, about 200 is responsible from the resources, the use of resources in the environmental body. Okay, so that so we can say, so resources, use of resources is responsible more than like okay, so the contribution to the contribution of the emissions on the human health is less than ecosystem, greater than ecosystem, and the contribution to the resources is more, even more. Similar things are here. The contribution to the human health is this amount, ecosystem this amount, and resources this amount. So this is the relative contribution of different parts we have. The cables contribution, the resources is this amount, environmental burden or environmental impact, I would say. The ecosystem is this one, and the human health is this one, impact on the health. So, and for the coffee pot, this contribution to the or impact to the human health is this amount, impact of the ecosystem is this amount, and impact to the resources is this amount. Okay. So now let's go to the inventory. This is the detailed of this. This is the detail of the material used or substances used in the system from the database, and contribution or impact from each of the material or resources used are given here, and the total is given here. So this is for the small parts, housing, main cables, and units are here given here. So this is the summary of the process contribution. So we have used aluminum, copper, glass, peat, injection molding, polypropylene, polyvinyl chloride, steel, and transport. So these are the main process and material we used, and out of 90%, these are the contribution or impact. So we can see the impact of using polypropylene is much bigger than others. 33%, 13% from the injection molding, 5% from the glass, 17% from the use of copper. Okay, altogether, and these categories are given here as well. Okay. There is nothing else we can discuss here. So setup is already we have discussed. Process contribution in okay. So if you go to the process contribution, you can get your results in tabulated form here or in the other form. Okay. So this is the table form. This is the graphical form of the measure processes, contribution to the environment or impact to the environment. You can use this kind of graph or this kind of, and you can show pie chart as well. This is already given. I've already explained that from the table. So this is a different form or different way of representing. You can do the settings for the chart here. Just click here. You can set the color and etc. etc. Okay, and then extract the graphs. So just copy chart to the Excel. Okay, you can just copy these graphs to the Excel, or you can just collect the data from the tables, from this process contribution tables. Collect the data from here in the Excel and plot the results according to your wish. But you can choose which one you want to see. Housing model. This one is the small parts. This one bubbles. This one is the coffee pot, etc. etc. Okay. So from impact. Okay. So I have to discuss this one. So impact assessment has different categories. First one is the characterizations. From here you can see about 18, I believe, 18 categories from different parts of you. We have defined like housing model, small parts, main, and coffee pot. So climate change, ozone depletion, impact category, human toxicity, is process contribution on human health. Okay, on human health, these processes contribution are given here. This resource. Okay. On the human toxicity, main cables is more responsible compared to others. You can understand this is made of polyvinyl PVC or polyvinyl chloride. So there have some toxic substances here. So that's the reason human toxicity is severe in using cables. Okay, housing model, photochemical oxidation. This housing model is more responsible than others. For example, what else I can discuss? Like similarly, for ionization radiations, climate change, ecosystem, terrestrial acidifications, freshwater eutrophications, terrestrial ecotoxicity, which I have all those, like most of them I have discussed in my past tutorials. If you can, if you have time, or if you go through this, I have discussed all this, like which contributes what, climate change, acid rain, smoke, scarcity, toxicity, what contributes, what I have already discussed in my past tutorial. So you can just go through that video. So okay, so damage assessment, we can extract the results from the damage assessment on the human health, ecosystem and resources for using housing, small parts, cables and coffee pot. So these are the contribution in percentages given. So this is the normalized results. So I would suggest to go through those tutorials, or I will make another tutorial for the theory of this, like what is characterization, what is damage assessment, normalization, weighting and single score. So I have already explained this one, like in the theory of the SimaPro. You can go through this tutorial and you will be able to understand what are those means. And weighting is another one, like in human health, ecosystem and resources. So impact of all those in the ecosystem and resources. A single score is another one. So contribution from the using of housing is this one. Is the more you can see, the more contribution or more impact by the making of housing. You can get all these results from here as well in the tabulated form, so that you can define or you can make your own graph. I think you have understood the basic principles of using SimaPro software. So I don't want to go further from here. Just close this one, close window. I'm closing this one. Okay, so this is all about this assembly made of plastic, and similar things has been already defined in this model. So how we can compare this, I will be discussing this one in more detail about aluminum one first, and this comparing with the plastic one, and interpret the results. So these are the all four stages or all four phases we have for the life cycle analysis. And interpretation means like when you compare the results, of like two systems, like plastic one or aluminum one, then you can choose which one is better or which one is more environmentally helpful or more environmentally friendly. So you can suggest to the designer, okay, this one has this impact, this one has that impact, so this one is better than that one. So this is the interpretation of the result based on this one. This is all about for this tutorial. I will be discussing and comparing these two in the second tutorial, which I will be discussing soon. Thank you very much for watching.